Good morning, everybody. My name is Richard Worsfold, and I'm with OCE, and I'm actually your warm-up act till we get people sat down. When we plan discovery, we try and plan topics that are timely, topics that relate to the types of projects that we get involved in, and projects where we think there's an opportunity for us to expand and grow the value chain in Ontario. And so I'm responsible for actually setting up this agriculture panel. And when asked why, I pointed out that the aerospace industry employs 25,000 people, and the auto industry employs 25,000 people, forest industry employs 25,000 people, the agricultural community and the food community employs over 100,000 people. It kind of makes sense for us to be able to discuss that market and that value chain and things related to it. Plus the fact that agriculture is probably one of the most innovative operations in this province in terms of the new technology of the 21st century. Some of it you'll hear about today. But the other thing is that OCE is an industry-directed, led organization. We want industry to be calling the projects. And if you stop and think for a minute, agriculture has the most small or medium enterprises in the province. Every farmer, anybody who invests in agriculture and has land, he's a small business. And we want to reach out to the small businesses. I will talk 30 seconds longer because I see a couple more people coming. So today, actually, at OCE, if somebody mentions agriculture and I have to find out something about it, I have a go-to person. He's going to be our moderator, Gord Surgener. And Gord is going to control the presentation for the next hour and a bit. So Gord, being my go-to person, could you please come up and take the stage and introduce people?
Well, thank you very much, Richard. The first thing I want to do, though, is say thank you to you, Richard, for organizing this. And thank you to the superb staff, the double Sarah, I will call it. I got Mawson and I don't say Farley. Anyhow, I hope I got that right. But the OCE has been absolutely great. We're starting to see what I will call agriculture and the intersection of the disciplines beyond what I will call traditional agronomy are becoming bigger and bigger factors as we go forward. I'm supposed to segue into the importance of agriculture, and Richard put out a couple of key points, but my first thing is going to be actually to introduce the panel. I'm going to introduce them all. It'll give you a flavor of the diversity of topics we're going to talk about, and then I'll introduce the actual why we're here, really. So the first person, and we've got them in order, as they will be speaking. Our first panelist is Alan Scott. Alan, put up your hand. There we go. Alan is project scientist at ComDev. So we've got satellites and imaging, part of agriculture. Alan has extensive experience in the field of space-based optical remote sensing. He is co-chair of the Canadian Space Exploration Program's Signature Technology Consultation Committee. And here's the key. He is currently technical lead on a business and feasibility study to adapt this technology to build modular farm stations in Canada's north. And we have a number of people from Northern Ontario here as well. Our next panelist is Dr. John Kelly. John is the Vice President of Erie Innovations, and he's also Vice President of the Ontario Fruit and Vegetable Growers Association. The mandate of the Ontario Fruit and Vegetable Growers is to diversify agriculture and food opportunities to the sand plains of the South Central Ontario region. Basically southwestern Ontario, in around Norfolk, Simcoe, Ontario, what we call the sandy soils. Used to be tobacco land, and you're seeing a huge diversification occurring, and John is taking the lead on that. Throughout his career, John has been focused on innovation development and implementation. He's actively advancing products and technologies in the food, biotechnology, pharma, and the bioeconomy sectors. And that's one of the key things I do want to emphasize. You know, when you think of agriculture as food and feed, Well, now it's pharmaceuticals, it's car, we do a lot of work on car parts, it's fuels, etc., and we're going to be talking more about that. Our next panelist is Dr. Jim Brandle. Jim is currently CEO of the Vineland Research and Innovation Center, a position he assumed in 2007 when it was a startup organization. Jim is a passionate advocate for the horticultural sector. He leads a team of 70 plus research scientists and support staff in consumer and sensory research, horticultural production systems, and applied genomics. Apparently, here's a very important part, starting with the consumer and starting with market pull rather than what I will call production push. Through Jim's direction, Vineland has emerged as a leading center for innovation and industry outreach. Jim, thank you for joining us. And our final presentation is by Dr. Alan Darlington, the president of Nedlaw Living Walls. Alan, put up your hand. Alan, I assume you were a graduate student of Dixon over there in the... You bet, eh? In 2001, Alan seized the opportunity to spin off a company called Air Quality Solutions Limited by commercializing technology he developed at the University of Guelph with Mike Dixon. In 2007, this morphed into Nedlaw Living Walls Incorporated, and now has over 200 installations under his belt. Alan and Nedlaw are world leaders in the area of biofiltration in buildings, and I call it improving sick building syndrome. So with that, I'm going to introduce, I've got 5 minutes to talk about why we're here on agriculture. If I could have my slide deck come up, please. And I know I'm not supposed to press any buttons until it does, right? There we go. Everybody's got it? Good. So really what I wanted to do is elaborate a bit on what Richard has said. Agriculture's on a bit of a roll right now. We all have to eat, and we probably all have eaten a little too much. But just a couple of key factors in this. We're the largest sector in Ontario, which includes agriculture, food, and food processing. And I want to emphasize there's a world beyond just the food side and feed side. Agriculture and its related industries provide 1 in 5 jobs in Ontario. We have over 57,000 farms in Ontario, which is about a quarter of the Canadian farms. They're a lot bigger out west, but we have a lot more of them. Southern Ontario corridor, this area of Southern Ontario is the second largest food production region in North America, centered on Toronto, which is either second or third in North America, depending on how you do your math, but you look at London, Ontario, Kitchener-Waterloo, the whole region. It's the single largest employer in Ontario's, in the driver of the bioeconomy. And you're going to hear that we're looking at alternative energy, we're looking at pharmaceuticals, we're looking at auto parts, we're looking at new types of biochemistry. And in my opinion, we are now a major exporter of agricultural products. We just crossed the $10 billion in agricultural exports out of this province. We have, it used to be, we are almost doing 10 billion. We have crossed the 10 billion mark. And we have an opportunity in this thing called the bioeconomy, which is that area beyond food and feed. Just a few more statistics. In Ontario, employment increased by 9.9% in the first quarter of 2010. If you look at total farm cash receipts, up by 11.5%. Our grains and oilseed guys have done extremely well, 22% growth in cash receipts. Livestock is up by 8.2%. Importantly, government payments to farmers have declined by 34.2%. And one of the key reasons is this word called innovation. And I do want to acknowledge our federal Agriculture, Agri-Food Canada and OMAF and our Growing Forward and the farmers of Ontario who said we want investment in innovation, not just checks. We want to make our money from the marketplace, not the mailbox, and I think that's very critical. So sales up by 41%, net income up 126%. The average net worth of a Canadian farm rose by $486,000. An increase of 47%. Net worth ranged from $190,000 selling less for those selling less than $100,000 to $1.9 million for farms selling over $2.5 million. People keep saying there's not a lot of capital out there. Well, there is a lot of capital when you see farmland selling at $15,000 an acre, and if you want to buy 100 acres, bring out $1 million check to start the negotiations. But how do we take some of that and put it into the innovation part is going to be a critical thing as we move forward. But the point here is our farmers are doing well, but it's all based on land. It's not cash flow wealth. There is now a high optimism. 77% of farmers are better off today than they were back in 2005-06. We used to have tractors going around Queen's Park. 58% of the producers plan to expand or diversify next 5 years. And 7 in 10 producers would encourage a friend or a relative to take a career in primary agriculture. It used to be, I would never have my children in there because it's like ripping up $100 bills. Well, now, actually, there is a considerable amount of wealth. It used to be, we said exports near 10 billion mark. Well, that was in June of 2012. We have crossed the $10 billion mark in terms of exports. And it's important to understand, if you look at the bottom, Ontario value-added consumer-oriented products accounted for more than 70%. So it's not that we're selling raw commodities, we're selling finished food products and value-added products. So we create a whole another level of industry within this province using that feedstock. It's a very diverse area, from animals to grain and oil seeds, sugar processing, fruit and vegetables, meats, bakeries, other food, beverages. One thing we are is incredibly diverse, which allows for a lot of stability as you go through the ups and downs of the markets. And importantly, we all eat. So we can't all say, well, I'm not going to eat anymore. You may change your dietary behavior, but we all eat. And we are taking a huge number of byproducts from that industry and converting them into value-added products. Another key point is that our food and processing industry accepts about 65% of the food-related production in the province. In other words, that product of raw commodity that comes off the farm goes into a value-added processing within our customer base of the Ontario Association of Food Processors, consumer food products manufacturers, those kinds of companies. That food and beverage processing, 3,000 food and beverage companies. As Richard said, #1 employer in the province in terms of actual numbers, not necessarily the highest salary average by any means. And what I want to emphasize and what we're going to look to in this panel is some of the new areas and why innovation is so critical. As Richard has said, I find this a highly innovative community. But it's really where, if we just stay as agronomists, which we're not, it's at the intersection of disciplines where I see huge growth opportunity. It's all about how everybody gets fair return for labor and investment. If we don't have every step in that food chain getting fair returns, it will not be sustainable. It's a lot more than food and feed, and I really have to emphasize that component. And a special thanks again to Ontario Centres of Excellence and all their people. I've been working with them for a number of years. They have been great in encouraging greater involvement in our agriculture, food, and bioeconomy, and they deserve a lot of credit for working with us historically. And I have one last slide. And I had to have something that was kind of folksy from agriculture. Pioneers get the arrows, and the settlers get the land. When we talk about innovation, a lot of that revolves around the pioneers, the people breaking the frontiers. Well, how do we de-risk that? How do we make the probabilities of success for those companies that are taking those high risks? And I think Ontario Centres of Excellence has done a great job in helping to de-risk that for the pioneers. And you're going to hear from some pioneers. With that, I'm going to turn it over to Alan, and we're going to go into outer space, I take it.
Thank you, Gord. And thank you, Richard, also for giving me this opportunity to address everybody. I guess it's kind of incongruous that a physicist from ComDev would be addressing a conference on innovation in agriculture. And I certainly wouldn't have expected it myself several years ago when I got into this field. The reason that ComDev is interested in agriculture, we got into this looking at the challenge of growing food on the moon and Mars for astronauts. And much to my surprise, I found that Canada was actually a world leader in developing the technologies and the systems to do this, to grow food in controlled environments, mainly through the work of the Controlled Environment Systems Research Facility at the University of Guelph. Mike Dixon is the leader of that group, and he's in the audience today. So we were really interested in the possibility of how to do this. And what we learned through the process was that the technologies needed to grow food on the moon and Mars with a minimum of resources and a minimum of waste are identical to the technologies that we use to feed people on the Earth. And the problems that a future habitat in space would face in keeping people alive with supplying food are very similar to the problems that Canada faces feeding our northern communities. It was a bit of a shock to find out that Canada actually spends on the order of $15 million every year mailing food to 140 northern communities. We could actually use these technologies and apply them in the north. And that is one of the things that we tried to work on. In fact, the technologies to grow food in the north are the same as the technologies that they need in the desert in Kuwait. We are looking at using LEDs to more efficiently deliver light to plants and increase the productivity of plant production systems. And you can see on the slide here a picture of the research facility that we've developed in collaboration with NSERC and OCE and the University of Guelph to actually test the wavelengths of light that plants respond to and to play with the wavelengths of light and actually change how the plants grow. You can actually use just the colors of light that the plants use. The sun is an inefficient source. There's clouds a lot of the time. Greenhouse production needs a lot of area to produce a very little amount of food compared to what we can do in an enclosed environment with LEDs. So it's always been infeasible economically to grow food in the north when there's limited light. When you're up in the Arctic, for example, 6 months of the year, you don't have enough light to grow plants from the sun. So if you want to have a continuous supply, you need to supplement and even do all of your production potentially with LEDs. So we are doing research with Guelph to look at how to use lights to change how the plants grow, to make them flower earlier, to make them more productive. You can actually change the characteristics of the plants you get depending on the light that you supply. And we've built up a world-leading research center right now, probably the best in the world, to actually look at this. Surprisingly, these things haven't been looked at. So I've got a few slides here. I'll go through them randomly. I'll flash them up. I don't have time to give you the full spiel at this venue, but if you want to talk to me about it, please see me after the talk. So we've been working recently on a study with the government of Northwest Territories and the Canadian Northern Federal Development Agency, looking at the business feasibility of actually putting together a business that would produce food in situ in the north and address some of the problems that Canadians are facing up there. The nutritional deficits. People are basically eating pop and chips in some of these communities because that's all they can get that's edible. If you look at the Yellowknife supply chain, things go from Mexico to Edmonton by road and then up to Yellowknife by road. They're 10 days on the road getting there. Think about the shelf life of fresh vegetables, strawberries, for example. If everything you're getting is 2 weeks old and sitting on the store shelves and it costs $20 a kilogram, you can see there is a potential business opportunity. Now, the market isn't very large in northern Canada. There are lots of markets worldwide that have the similar problems with product production and food security that these technologies can be applied to. So we've done the business study, we're finishing up on the report, we've looked at the feasibility, and you can see that there is a feasible business case for producing food, even at wholesale prices in the north. The systems we're looking at, very straightforward. We have lighting, we have air handling, we have very good environment control, and it's all in a very, very small space, so that it's very easy to control. You have a high density of production. We're looking at originally high value crops for the business case. Food is not the best thing that you can do in terms of profits, but it's what we were asked to look at because it solves a lot of other problems in terms of the nutrition, the health, and the fact that it's already being subsidized by the Canadian government. And we can address that potentially commercially. The challenges are the power. The cost of power to provide this are sometimes a challenge, especially in diesel communities in the north. But hydro communities, it's quite an attractive option. And this is just a picture of the Guelph facility that we're working with. The interest here, ComDev is now looking to work with OCE to spin off commercial options. We're looking for partners who are interested in taking the technologies we've built up in terms of LED lighting, nutrient sensing. We've developed, are developing and testing at University of Guelph fiber optic nutrient-specific sensors for hydroponics. There's a lot of technologies that need to be developed and are being developed and have potential, very good potential for commercialization. So we've gotten to the point where we're ready to look for partners on this. So that's another reason that I'm addressing you today. If any of you are interested in these sorts of technologies, please come and talk to me, and we can work out a way to go forward with this and make something happen on Earth that eventually can go into space. And the good thing about this is that all the research that we're doing is useful in the long term. So it's got a dual use for humanity. The same technologies are of continuing use in the long term. And I see this as very attractive from the standpoint of a space scientist, because often the technologies that are developed for space and space exploration are useful only for a single purpose, and the money seems to be wasted in the long term. And I see this as a very useful use of the funds to develop space technology, because it has this obvious dual use and it has a long-term benefit for humanity. We actually developed this roadmap for Canada, for the Canadian Space Agency, to look at 3 different parallel lines of development: the Earth-based, the microgravity-based, and then the planetary or lunar-based technologies. And it's eminently feasible in a series of very small steps from current technology. There's no showstoppers on the road. There is a lot of engineering work, detailed development, pushing the productivity. But I think there is an end game here, and it's insight, and I think we can address the problems that face us in terms of the productivity that we think we can get in these enclosed environments. We can double or triple standard greenhouse production levels. The research is ongoing right now at the university in enclosed environment chambers with the high intensity LEDs. These aren't off-the-shelf systems. These are unique systems that have been developed for this project, and I think are better than anything that anyone else has right now. So we have a leg up right now, and we're really thankful for the support that we're getting from OCE to help commercialize these and develop commercial applications. We've been in contact with manufacturers of LED fixtures and manufacturers of horticultural lighting fixtures, and they're interested in helping us take these to the next step. So I think there's a lot of promise here, and I guess I'll end here, pass it on to the next speaker. Thank you.
Just a comment before I bring John up. You heard a couple of key words here. You know, solutions for the world. If we find the solution for our Canadian North, how do we apply that to the rest, Siberia, everywhere? So solutions for the world, I like that. And if you look at the multitude of players in order to do this, it's not individuals, it's teams. And again, I congratulate you for helping pull that together. Next speaker, John Kelly, and we're going to talk to you about hazelnuts. And by the way, you'll get to sample a lot of them later.
Thanks, Gord. And I'd like to express my appreciation to Richard, too. The Ontario Centres of Excellence has been very supportive of the development of the hazelnut value chain within Ontario, as has Ag Canada, OMAF, and other funding organizations. When we look at the development of any new markets, we try to take this value chain approach. And what that means is we just don't work on something at the university level or the academic level and try to push it out. We have to try and find those markets that have something that is desired, so we're really working with a pull market. And when we do that, we want to make sure that we work to the value of everybody within the market. So, when you look at the typical definition of a value chain, we look at strategic partnerships, we look at interdependent businesses, and we also look at collaboration. So these are three key things that we have to do. Has to be an advantage to whoever's involved with this, and there has to be a market focus on what we do. So when we look at the hazelnut development, for example, we have an end user who really wants to see development of hazelnuts within this province, and they want to diversify their supply chain. We have growers that are interested in developing the market and moving forward with that. We do this with all sorts of different products. We're doing it with the biomass developments that we're seeing for combined heat and power within the province. We've done it with lavender. We've done it with things like different wineries and those types of things. So it's a very good model on how to move things. And when you look at what a typical value chain looks like in agriculture, you really have these five main components. You have a technology provider, you have a grower or a producer, primary production as Gord was referring to. You have somebody who has to collect everything, so that's the aggregator. You have an end user or a manufacturer, and then you have the consumer. These look like boxes, but we have to remember that these chains are actually made up of people, and we have to have conversations along the value chain. And one thing that we have found historically is that we have good communication between the academics and the growers, but we don't have very good communication at all between the growers and the manufacturers, or the academics and the manufacturers. And we're starting to see a change in the perspective amongst all of these value chains. And so when you have technology providers listening to the market, then you're going to have much more rapid development of usable products, and that's really what we're after in the long term. So in particular with the hazelnut value chain, you can see that there's an awful lot of people who can be engaged with this. Along the left-hand side, you've got funding organizations, research groups like the University of Guelph, like the Vineland Research and Innovation Center, supported by OCE, Ag Canada, OMAF, and all the others. And then as you move forward to the right, you can see the components of that chain. You can see the companies that can be involved, whether it's Krause Nurseries, Morey Nurseries, St. William's Nurseries. These are all major tree nurseries that can supply these products to people who are growing. So further along, you see apple growers, you see the Ontario Fruit and Vegetable Growers Association. So now we're getting into the production of this area. And then the next step is aggregation. And you'll note that we don't have a whole lot of aggregators currently in the sector. In fact, we have zero. And that just tells you that this is a brand new market for what we have in this province. The key user of hazelnuts globally is Ferrero. So Ferrero is looking to supply them. They use about 55% of the hazelnuts globally. Their main source is Turkey. They also source from Italy, from the United States, and more recently Chile. And we're trying to not displace this, but augment their production because their growth is significant. But we can't just rely on one end user. So that's why we're looking at companies like Kraft and Nestle and Unilever and others, so that they can supply the end consumer who is going to buy from Longo's or Loblaws or Sobeys or internationally. The Ferrero plant in Brantford supplies the United States market, the Canadian market, the Mexican market, and the Australian market. So it's a huge, huge deal. So when you look at all the Ferrero Rocher that you've seen around here, and if you go to the University of Guelph Plant Agriculture booth, you can pick up some Nutella, right? That's all produced here. The Ferrero plant also produces things like Tic Tacs, which I never knew, Kinder Surprise, those types of things. So it's a very large privately held company and a key influencer in the market development. We also look at collaborations across North America. So when we look at the development of varieties and cultivars, for example, we're going to pull from wherever we can that meet the requirements of the customer, but also meet our growing conditions. So our pathway to market really is from the research to propagators, micropropagation techniques being done at the University of Guelph, nurseries, we work with farmers, aggregators, and then you can look at, we want to diversify the end-use products. So not only nuts for kernels going to manufacturers, but also nuts in shell going to the fresh market. We want to find uses for the byproducts or co-products. We don't have any waste products in agriculture anymore. We have products that are looking for a home to be productive. So when we look at the development of these markets, we have a number of steps to go through. You know, whether it's identifying what the customer wants, the product concept, the raw materials, those things, they have to meet the product safety and specs of the end user. We also have to think about, well, how can we add value to those products? What's the marketing message? What's accessing to the market? And you notice that none of these things talk about agronomy. These are all market development. They're all development of business. And right, this is something that's very important when we look at the development of new products. So a key challenge for hazelnuts is eastern filbert blight. And you can see that the cankers that grow on these are significant, and they will eventually kill the tree if you don't have an eastern filbert blight resistant tree. This is what it looks like on ornamental hazelnuts. If you think back to I think it's the Harry Potter movies and the actually, no, it was Gandalf. In Gandalf's staff, he had a hazelnut staff, right, because it looked very cool like this, but it's a real problem. Cold hardiness, so cold tolerance we have to go through. So the catkins are quite susceptible to cold here. So we have to try and develop cold hardy varieties. So we have to look at where are these going to grow best in Ontario. So this is part of the development for growers. So if you look at down in southern Ontario, zone 7A, that's Essex County, you look at Niagara, there's some areas there. Those would probably be the first areas that we would like to see the development of these hazelnuts. We currently have about 60 acres commercially in the province. We think there's a market for more than 20,000 acres based upon the end use requirements. And their main plant is in Brantford, so that we're ideally suited for these developments. We have our own developments that are happening with micropropagation of current varieties. That means we can rapidly increase the numbers of trees, transfer this technology to a company called Harster's Greenhouses, who then will transfer the products to different nurseries across the province. So when you look at the development of these things, you know, we'll have potted trees perhaps, or we'll have trees fully in nurseries. We'll have the research and development to look at the different cultivars. This is a picture of Adam Dale, who has certainly been running with the development of hazelnuts in the province. And then we have to get growers involved. So you can see the existence of the chain right from academic to growers, but we haven't got it further developed. So the next step is developing the business. So we have to have a very good product development strategy moving these things forward so it benefits everybody along the value chain. So we want to make sure that our nurseries, our micropropagators, our growers, our end users are all having great value from these products. We think this requires a lot of collaboration, and so far we've seen that across the value chain. So if you have any questions, let me know and we can talk later. Thank you.
By the way, as you've probably figured out, we're going to do all the questions at the end, and that way we can all participate in the answers. A couple of key words that I received from John's talk. One is collaboration, again, but vertically, all the players to get it to the final consumer. And there is a difference between the customer and the consumer, I want to emphasize from the producer's standpoint. And the other one is that we don't have to invent it here. So we're bringing in the best varieties from around North America and evaluating them. So I live by a quote, research is global, implementation is local. And the ability to bring all the players together and work on a project from start to finish, and they're all at the table, I think is a unique competitive advantage that we have in Ontario and in Canada. And I see it in the auto sector, I see it in hazelnuts, and I see it in a whole bunch of fruit and vegetables. And I'm going to invite now Jim Brandle, Dr. Jim Brandle up, head of Vineland, and he doesn't like that, just Jim, right? And explain, it's a whole new experiment in terms of research and the way we're doing business in research and working with our customers. Jim?
Thanks, Gord. Thanks for the introduction. Thanks, Richard, for putting this on and inviting me. I got to set this on tall. Is that all right? There we go. So, and I got to thank everybody who came here who probably fought the slings and arrows of outrageous traffic to get here by 9 o'clock. I took the train, so it was rather relaxed, even though I thought I was going to be late. So I'm going to talk a little bit about Vineland and a little bit about some of our project work as well, because sometimes, and what's become apparent in the past probably decade or so, is that we need to innovate how we innovate in order to be effective, that old systems and old ways aren't necessarily anymore the best way to approach things. Sometimes you need new models, new organizations and new people to address these things. So I could push the button now. First slide, and this is a little bit of a repeat of what Gord said, and I'd have to also say when I talk to growers, that usually I have to apologize for being so positive. But many things are going well for agriculture. They're going well for agriculture in Canada, they're going well in the US, and they're going well in the world. World population is growing, right? We're at 6.5 billion people right now. We're going to be at 9 billion in 2050, and we got to feed everybody. We got to increase our production by 75% between then and now to feed everybody, right? So that means demand is going to be fantastic. The professional financial risk takers in this world have created things called farmland funds, where they're buying up huge tracts of farmland and leasing it back for production because they think it's a good investment, right? So agriculture is strong. Grains and oilseed sectors, you don't even have to say it, but they're doing absolutely fantastic. Prices never been better, income's never been better. Farm size is increasing, Gord just said that, and revenue is growing by nearly 4% a year. So things are good, right? And if they're good and we want them to stay good, right, what do we need to do? Of course, we need to innovate, right? I got to go faster. Gord. No. All right, I'm doing okay. All right. So if we want to talk about the future, though, we need to talk about the past. So a little bit of a lesson here around how we have gone as far as we have and how we need to continue to do that in the future. So if you think about innovation in agriculture, the first thing should come to mind is the fact that agriculture itself is an innovation. 10,000 years ago, somebody thought up this idea to start to domesticate plants, and this is what caused a shift in our society from hunter-gatherer to the modern agrarian society you see today. And then major technology shifts have helped us grow population and feed everybody, right? So Malthus was wrong. We're not a flask full of bacteria, right? We're not going to boom and bust. We're a rational species. We can think our way through this, right? And we have. So the critical thing about innovation in agriculture, Richard, is not just important for our economy. That's cool. It sustains our species. That's how we stay alive. So I'd say it's worthy of investment, not only public investment, but investment by everybody, like the air we breathe and the water we drink. So what about us? We're new. We're a new organization, a different construct, right? We're an independent, not-for-profit organization focused on horticulture. Our results are something meaningful and real. So that's acres in the field and shelf space in the grocery store. Our horticulture, like John said, includes the whole value chain from producers through to consumers. You can even see that reflected in our board. We're not-for-profit. So that means we're stakeholder focused. We're here for one reason and one reason only. We're not educational, we're not political, we're here to support horticulture. That's it. And we're independent. Government is neither member nor director of our corporation. They're a major client, no doubt about that, but we have an independent, policy-driven business board. How do we do it? Very simple model. You need three things to increase the probability of success of your projects, right? The first thing is a right consumer concept and the ability to validate that. Not just that you watched the Food Channel the night before and you had an idea. And really there's some numbers underneath it that says, hey, this is great. You need the right science, right? So that's okay, a bunch of PhDs, we're pretty good at that part, right? So we can figure that out. And you need commercial partnerships because we're not a seed company, we're not a nursery, we're not a grocery store. You need those business partners to help you deliver. So what about Ontario horticulture? It's a $2.3 billion a year business. That's worth paying attention to. Greenhouse flowers and greenhouse vegetables are now over 50% of that. Very large enterprises, right? Very successful. Key piece is cost of production. What do you see? 43% is labor, right? Heavy dependence on offshore worker programs, and those programs only address labor supply problems, not labor cost problems. Our problem is cost of goods. Our stuff is too expensive. We've got too much labor in the mix. So if you think about it, what do we need to do? If you look at conventional agriculture, we invented the combine harvester, right? 100 years ago, and wouldn't it look funny if we had to drive through the fields of southern Ontario and people were cutting and stooking grain, tens of thousands of them, right? Well, we're still doing that in horticulture, so it's got to change. And so the combine harvester for horticulture is a 6-axis robot. $38,000, you can buy one on the internet if you can figure out how to teach it how to do something. And you need the partnerships to deliver that labor-saving technology. So there you go. Again, unusual relationships for agriculture. We've got AEMK from Waterloo, spin-off from that university who makes Delta bots. Harvest Robotics, who does the machine vision systems from Mac. Niagara College, where's Mark? There he is. Delivering us, the co-op students, we need to actually do the work, right? Pioneer Flower Farms, CMP, Cambridge Metal Products. They're the guys who build the work cells that the robots sit in, right? John G. Wilson, again, manufacturing robot cells for us to actually work with. Monaghan Mushroom, Sunrise Greenhouse. All of those people together make up this project. Just quick, I'm running out of time. We got a planting project. We're working at the tail end of the labor flow, so planting and packaging. Great progress there. If you want to go over to our booth, it's 1032, I believe, and have a look. Or talk to John Van de Vecta there on the left, who does the engineering. So these machines are in greenhouses right now being beta tested, doing planting. It's also a versatile machine. It does bulbs, it does cuttings, and it does seedlings. Packaging technology, same idea. This is a 4-axis robot. Those things are all out in the field right now, working in greenhouses as we beta test and optimize those things for use. All of this stuff will then catalyze the introduction of those machines into the horticulture industry. And not only that, it creates an opportunity for our horticulture industry, and it creates a global opportunity for our robot and automation manufacturers. So here's what we're trying to do. Catalyzing partnerships to grow horticulture. No more old model where I work by myself. It's all about me. I love myself is what the little badge says. And if you partner with everybody, that's how we take our 70 people and turn them into 7,000. That's with partnerships. So that's the connection model. Okay, that's what we need for the future. With that, thanks a lot, Gord.
Thank you very much, Jim. And once again, you heard words like global. Another key aspect that came out in Jim's presentation is not just the product that you sell and all the attributes of the products. It's the attributes of the process to get there. I'm working on injection molding right now, and the product is good, but where we really sell it is it goes through the molds at 10% faster. And unless you're there in the processing part of the equation, you'll never know that. So it's not just the product, it's the process. And I'm going to switch now, as the panel will switch, to something beyond food, so something actually very beautiful. And I'm going to ask Alan to come up, and it's an example of taking technology from the universities, you know, the old professor model, and turning it into a company and selling it all through North America. Anywhere outside of North America yet?
Getting there.
Getting there, good.
Thanks, Gord. Okay, thank you very much. What I really do is take agriculture, and instead of the old idea about food and feed, it's air. We generate clean air. We say that, you know, everybody eats, but at the same time, everybody spends their time indoors. And being indoors, we're very dependent upon artificial environments, is that we're dependent upon mechanical systems to give us the air quality we need. There's 2,500 people in this conference, which means that roughly 20,000 CFM of outside air is being brought into this building every minute, cubic feet per minute. If you look at even a day like today where it's 20 degrees outside, you have to take that air that's 20 degrees and cool it down to 15. It's a huge energy drain out of the system. What we're looking at with this indoor air biofilter is reducing that need. There we go. So to step back and actually go through the whole process is that, you know, again, that we live in Canada. It's a very hostile environment in terms of the outside temperatures. It's cold in the winter, hot in the summer. So we have our buildings, and to get through them, what we do is we seal them. We have windows that don't open. We wrap the whole building in plastic, and it works really well at keeping that tempered air inside the space, but it also allows all the rubbish in the air, the off gases from furniture, building materials, people, the activities, accumulates to the point of actually being detrimental to the well-being of the occupants. Now, the way they traditionally deal with this is through ventilation. They take that outside air and bring it into the building. It's the old solution to pollution is dilution. So they blow the dirty air outside and they get rid of all the crud and corruption. And it works really well, but you have to take that air again. Even today at 20 degrees, you have to cool it down to 15 degrees before bringing it into the building. And it's a huge energy requirement in the building. About 20 or 30% of the energy consumed is bringing in that additional airflow. So it's a huge drain on the environment, and like the sustainability of the buildings. So our idea is, well, can we really go back to basic principles and say, with biology, if we take the right system and integrate it into the building, can we use that as an air polisher and use that to remove the garbage in the air? And then what we can do is either reduce the amount of outside air we're bringing into the building, so we have less demands on the environment through energy consumption, or we keep the air coming in at the same rate and enjoy a higher quality of air quality for the occupants. People's performance is really tied to how good the air quality is. Bringing in more or giving them better quality air means you get better performance. So what we did, and again, through Mike Dixon's lab, and this is really a great story for the, I mean, this has come all the way through OCE. When we started with Richard, it was actually the Institute of Space and Terrestrial Science in the early 90s. So we've started there as a very fledgling technology, moved it through the research program. I took it and then ran with it as a company, and we're still associated with OCE, so it's a really great story that way. But we took this technology of looking at biological systems, subjecting them to toxins and seeing where they went, and then looking at how we can make it into a real product. And really what we've done is come up with basically combining 3 standard industrial technologies together into one unit. We've got biofiltration, which is the passing of a contaminated air or water stream through a biologically active zone, where beneficial microbes take the contaminants and use them as a food source. I always use as an example when you're outside and you have a coffee and you drop a little sugar on the ground, you don't really have to worry about sweeping it up because the ants come and take it away for you. And that's exactly what happens in a biofilter, but instead of dropping sugar on the ground, we release formaldehyde into the air. And instead of having ants come and take it away, there are microbes, bacteria living in the biofilter that consider it food. So they'll take it out, pull it out and degrade it. They'll eat it, there's nothing left. It's a little bit like an activated charcoal filter, but an activated charcoal filter is a sponge. And because it is a sponge, it just holds on to it forever. This is like that activated charcoal, but it's self-cleaning because as the materials go into the filter, they're pulled out and eaten by the microbes. The other technology is Phyto Remediation, which is considered a brownfield technology. If you have a soil that's contaminated, they find if you integrate green plants into it, the plants will facilitate the breakdown. It will all happen faster. So these are the 2 cleaning technologies, which are widely used in engineering. The third technology is just straight agricultural hydroponics. All we have is vertical hydroponics. We have a water reservoir at the bottom. It lifts the water to the top of the wall and it flows down through that porous rooting material where the plants are growing, and that's hung in front of the air diffuser. But it's really just vertical hydroponics. We're doing the exact same thing they're doing in greenhouses. Instead of like this, we're doing it like this. And instead of growing tomatoes by passing air through it, we grow clean air. This is a project we recently did at Drexel University. And again, it's this vertical hydroponics. You look at it, and it looks like just a plant wall. But behind that is a whole series of hydroponic control systems. This is actually the insert is the floor below. And down there we have pumps, controllers, and all those things regulating the flow. It's just agriculture in a new venue. And again, here's just a schematic of the way it works, and anybody familiar with hydroponics, all the parts are the same. All we've done is taken what's out there, put it in a new box, and getting a new product, clean air. It's really neat and really pretty, but if it really doesn't have an impact, it is just that, it's just pretty. This is the sort of work we've done with the university looking at the impact of the technology on the real world. The top red line is a theoretical curve on the calculated concentration of volatile organic compounds in the air under a range of ventilation rates, how fast you're bringing air into the space. If you increase the rate at which you're bringing in outside air, the concentrations drop. If you slow it down, the concentrations build up. It's a simple dilution, and it's all set to a relative concentration of 100% at 7.5 liters per second, which is a standard ventilation. The blue line is how much the air quality is changed by putting in a biofilter into the space and keeping everything the same based on our specifications. And so we say that for our specifications, 60% of the volatiles are removed with a single pass if you move air through at 100 liters per square meter per second. You do that, and back to your reference point of 7.5 liters per second, put in a biofilter in there, you'll get a 30% reduction in the VOCs. Or the other way of looking at it is that if you reduce, you can actually reduce the amount of outside air you're bringing into the building from the 7.5 liters per second down to almost 2 liters and have the same air quality in the space. So it just reiterates that you can either use it to improve air quality or improve the building performance. The black line at the bottom is an actual biofilter's performance. The top line is our specifications, what we basically guarantee in our systems. The black line is what we actually routinely get in the biofilters. So with the biofilters, we're getting almost a 50% reduction in the volatile organic compounds in the system. The business model is pretty I was going to say straightforward, but it actually took some time to figure out, we've got a product, how do we make money off it? We design, build, and maintain these systems across North America and looking at international. Each of these are very different and have their own models and based upon territory and such, but it's been very successful for us to date. And as we're expanding, we're actually probably going to be turning into more of a design company than anything else as we're getting further and further away from our base. We've got the projects across North America. The American market was slow, and anybody who said that Canadians are less or are more cautious than Americans hasn't been in the building industry. The Americans were very hesitant, or were slow to pick it up until we really had experience under our belt, but now they're really beginning to pay attention. We have projects right across the Americas, and even locally in Toronto, we've got the reference library and such. But we've got roughly 200 installations across North America. So, thank you. Okay.
Well done. First of all, I'd like to thank all of our speakers for keeping us right on time. And again, one of my take-homes from this is we sell knowledge as much as we sell product. This is about a knowledge-based business, and we're selling knowledge because you have to put the whole package together. It's not just the living wall. So with that, we are now have an opportunity for questions, and rather than me starting the questions, I would really encourage the audience, anybody that has a question of our audience, please identify yourself and who specifically you would like to answer the question, but we'll allow everybody to comment.
Excellent. My name is Marc Nantel. I'm the Associate VP of Research at Niagara College. I too am a physicist who didn't know I was going to work with scientists who do horticulture, agriculture. But our chair in precision agriculture and environment technology, Mike Duncan, often says that farms are a business. And I'm glad to see that business is good. I'm glad, Gord, that you showed that, because he says that, if farmers figured out that growing rocks made more money than growing food, they would grow rocks, and we'd indeed do, right? My question, and it's probably to you actually, Gord, is you showed how better farmers are doing right now, or the whole value chain, but what are they doing with that new money? Or are they paying old debt? Are they going to buy Jim's new robots? Are they going to install Mike Duncan's new precision agriculture stuff to get better at doing what they do? Or, I'm interested.
Well, I'll just, in case anybody, what are the farmers doing with all this money that they're picking up in the sale of land, or where are they getting the money to buy land, I think is another one. Again, the average land price has doubled since 2008. We're now looking at, in good growing areas, $15,000 an acre. So one, it's the retirement plan for those people who sold their farm.
Right.
We're seeing we continue to see consolidation. So what's happening is it's other farmers that are buying the land. And one of the reasons why it's staying internally and is land-based, I mean, if you look out there in the world today, where are you going to put your money? Are you going to put it in a savings account at 1%? No. You're going to put it in a stock market that you don't understand as a farmer, or at least most farmers don't understand. Or do you put it in land where you do understand it? And just to put this in perspective, you know, we did a survey on a project we were working on and surveyed 15 producers, farmers, to say, how would you react to this? And the government said, well, it's only 15 farmers. Those 15 farmers had $500 million, not million, but $500 million in assets when you looked at their land and equipment. So, and again, back to the concept that these are major businesses. So you're seeing that consolidation and the money's going into that consolidation. So there's fewer farmers, bigger land base, more efficiencies I would put into that, and that's why labor and robotics are very critical. But a lot of it's going back into land or into retirement plans is where the money's going, and it's simply, I think, a confidence factor of what these individuals know. I would love to see some of it going into equity funds to invest in certain projects that we're working on, but we're trying to convince them of that. But again, wherever you're trying to, you know, change the dynamics, it's a slow, cautious process, because if you have some failures right on your first investments, you're not going to get more. So I think that's the best I can answer. Anybody else want to comment on that?
It's a pretty thorough answer.
Yeah.
Well done.
Well done. Sorry. All right, anybody else on a question here? Please identify yourself and who.
Greg Perry from the University of Guelph. Just as a question, when we're dealing with innovation in agriculture, how do you feel when we're dealing with a global society in particular where there's different degrees of resistance towards any type of new development, whether it be mechanistic or in the instance of GMOs, where, you know, in North America, for instance, there's not as much resistance towards GMOs in the marketplace, but for getting that crop over to Europe, it's a big issue. So, and same thing with new technologies dealing with harvesting, planting on the mechanistic side, we just don't hear about that as much. How do you feel that basically breaking through that barrier of knowledge and getting into acceptance for new innovations can be handled?
I'll start with Mr. Robotics to answer that.
So, you know, that's an interesting question, and I think that, you know, you heard it from John, you heard it from me, and it's really the way you do it is by including everybody at the beginning. Right? The failure of GMO is really a failure to include all the people who are impacted by that technology in the play, right? So they thought about their customer but not the consumer, and,
right.
and as a consequence we've got a multi-trillion-dollar technology that's now a multi-billion-dollar technology as a consequence of that failure. So I think if you take that approach and you build everybody in, I think you can do it. I mean, and the other thing is, of course, don't do stupid things, right? There are things that seem cool, but people aren't going to like them. So that idea of the baculovirus with scorpion toxin, it kills insects, but you got to think that one through. So from our standpoint, that's how we try to manage it, right? And talk about it and be transparent about what you're up to.
Anybody else want to comment?
What I think is you have to start with I always say the back of the napkin calculations, and whether it's a GMO or plants on a wall. You have to have enough of a model that will get you through where you want to be. And if it includes just a local parameter, like again, with plants on the wall in southern Ontario, you have to know that you'll make a living at it. But if you want to expand it, it's just the back of the napkin, and you have to look at where you want to be and how you're going to get there. But it isn't, again, the GMO idea of where it's all of a sudden a big surprise that somebody else doesn't like it. They hadn't done their research properly. And so I think really good business modeling is what it really comes down to.
Yeah, I'll echo that too. You have to have your end market in mind, but there are lots of different markets besides the European market, right? So the GMO, if you look at the adoption of GMO around the world, it's immense, right? And the European market is softening towards GMOs. We know that's happening. We had a fellow who was a staunch anti-GM guy for years and years until he started to go through the literature and said, oh, well, maybe it's not so bad, right? So part of it is having the right information out there and make sure that the right messaging gets out there as well.
If I were to comment, which I will, the first thing you have to do is answer what's in it for me. Back to the airspace, the quality, savings on energy, et cetera. What's in it for me? One of the problems, as Jim has alluded to, we looked at it, what's in it for the farmer, not what was in it for the consumer, and unable to explain that. It was also bad timing, mad cow was going on in Europe. There's a whole bunch of issues like that. But I do want to emphasize that, and I'll look at this, that it is a tool, GMO I'm using now, that has to be regulated. We regulate novelty. You regulate the product, not the process, is the proper way that science regulates. And in Canada, we have the best regulatory system. I want to get that across as well. Okay, anybody else out there? Please identify yourself, Errol.
Errol Caldwell with the Rural Agri-Innovation Network. It's a partnership between Algoma University and the Sault Ste. Marie Innovation Center. And I thank Gord for mentioning that there are some folks here from Northern Ontario. I'm from Southern Ontario, as well as most of you. When people think north, they have a hard time thinking north of Barrie, and that's an issue that we face every day. And yet, the agricultural area in Northern Ontario is either east or southeast of Winnipeg, and it's something we have to keep in mind. There's tremendous opportunity in Northern Ontario. It's 90% of the landmass of this province, and if you look at just the area within the Cochrane district, for example, there's potential, if properly developed, of expanding agriculture in this province by up to 16 million acres, and that's just phenomenal. At the same time, the feds no longer have a federal research facility in Northern Ontario. They closed the only one they had in Kapuskasing. The province and the University of Guelph are actually looking at cutting back or eliminating the research facility in New Liskeard. And this just stands in the way of a tremendous potential that we have. So I guess I don't really have a question, but I have a challenge. I don't have $10 million to put behind that challenge. But I do have a challenge to the panelists. I have a challenge to those in the audience, a challenge to the policymakers in this province. And that challenge is, how do we move that yardstick in Northern Ontario and increase agricultural production on land that is valued 1/10,
Right.
but just as productive in some locations, but valued 1/10 of what it's valued here in the south.
Anybody want to take it?
Sure. One of the things that, in a previous position, we always looked at the area around North Bay, for example, north of Lake Nipissing, where there was tremendous capacity for things like canola and some of the more western crops. As time goes on, we're seeing the development of cultivars that will, of more southern Ontario type cultivars that will survive and thrive in northern Ontario. So I would encourage that to continue. You have to make sure that whatever's developed has to have that end market, right? And that the viability for whatever is developed there can compete against everything else. So that's, like what you said, the business case has to be there for it to happen.
And it has, and Errol, we've had many conversations on this. You also have to have the infrastructure like storage, food processors. So it's not just about the farming side. We got to put the whole package together. And we have to game plan it one at a time. But the fact that your land is only 10% the cost with the same productivity on certain crops, the marketplace is already moving into that, I would emphasize. All right, I am here as the moderator, and we have hit the 10 o'clock limit, so I'll turn it back to Richard. But our panelists are going to be here. I apologize for cutting the audience off, but just to keep us all on time, you can ask them question one-on-one. How's that?
Yep. First off, you can nail them when they get off the stage, but they all have booths out here, and you can actually go and do one-on-one with them. Interesting. I'm going to use an analogy that Jim put up. We had 4 panelists today, but like the farmers 10,000 years ago, we could only scratch the surface to tell you all about this. There are many more interesting things that are happening. These people are not one horse acts. They're all involved in many things, so you may have questions outside of what we've done. But this wouldn't have been possible without the size. This is a good size audience for the type of things we do, and we've had good feedback. And I'd like to thank the audience for being here. I'd like to thank our moderator and our panelists. And I have a little gift for you guys, so don't go away. Thank you very much.